Welcome to my channel, Worldwise. I don't think people understand just how massive and powerful these ships really are. Let's start with the engine. This isn't just a lump of metal, it's a 12-cylinder, two-stroke behemoth, 5 stories high and weighing over 2,000 tons. The noise? It doesn't just rumble, it shakes the air itself. Every day this Titan guzzles 60 tons of fuel, about 1,000 car tanks gone in 24 hours. But here's the twist. It runs on liquefied natural gas, or LNG, chilled to minus 161 degrees Celsius. This ship is a floating thermos flask, built to be cleaner than its predecessors. Imagine a power station that moves, crossing oceans with a city's worth of cargo. Every component must be flawless. Failure in the middle of the Pacific isn't an option. Why build such a monster? Because global trade demands it. This machine is the future of how your stuff gets to you, a response to decades of pollution. It's a massive, complex solution to moving mountains of cargo without destroying the planet. The story of its creation is one of fire, ice, and steel. This is not just a ship, it's a symbol of ambition and necessity. Welcome to the Cathedral of Power. Shipping is the invisible engine of our world. 90% of everything you own has crossed an ocean in a steel box, but for decades, these ships ran on bunker fuel. Cheap, filthy, and polluting. The industry's emissions rival entire countries, and the world is demanding change. Enter CMA-CGM, a French shipping giant with a bold plan. Instead of tweaking old designs, they bet $9 billion on a new fleet of megaships powered by LNG. These ships would be the largest ever, cleaner and more efficient. LNG is cleaner but more complex, requiring new infrastructure and technology. The challenge: build 9 ships that are bigger, faster, and greener. They needed vessels that could carry record cargo, maintain speed, and slash emissions. It was a gamble, big, risky, and visionary. The result would push the limits of engineering and redefine what a container ship could be. The race was on to build the future of shipping, and the stakes couldn't be higher. The numbers are staggering. The CMA-CGM Jacques Sade is 400 meters long, taller than the Eiffel Tower if stood on end, 61 meters wide, 220,000 tons fully loaded. It can carry 23,000 containers, enough to stretch 140 kilometers if lined up. That's millions of bananas, thousands of cars, or the contents of a city's homes. Loading and unloading is a ballet of cranes and precision. The LNG engine and its massive fuel tank are at the heart of this design. The tank holds enough LNG for a round trip from Asia to Europe, 18,600 cubic meters. It's a cryogenic marvel, keeping fuel at minus 161 degrees for weeks at sea. Every feature, size, capacity, fuel system, is interconnected. The ship is a self-reinforcing loop of ambition and efficiency. This isn't just an upgrade, it's a total reinvention. A new era of ocean giants begins here. How do you build a 400-meter ship? Piece by piece. In a vast Chinese shipyard, the vessel is designed, then split into hundreds of blocks. Each block is built separately, some the size of houses, then welded together. Steel sheets are cut with plasma torches, shaped and assembled by skilled workers and robots. Blocks are coated, lifted by giant cranes, and joined in the dry dock. The ship grows, block by block, day by day. Quality control is relentless. Every weld is checked with X-rays and ultrasonic scanners. Even a tiny flaw could spell disaster at sea. Inspectors hunt for cracks or bubbles that could fail under ocean stress. This is heavy industry at its most precise. The result: a vessel built to survive typhoons and 30-meter waves. Perfection isn't optional, it's essential. At the core of this ship is its cryogenic LNG tank, a feat of material science. It holds 18,600 cubic meters of LNG at minus 161 degrees. Ordinary steel would shatter, so the tank is made from Invar, a special nickel-steel alloy. The tank is a box within a box, insulated with high-tech materials to keep the cold in. If the LNG warms, it expands, so insulation must be flawless. Testing is intense. The tank is sealed and filled with nitrogen and helium. Sensitive detectors sniff for leaks. Helium finds even microscopic holes. Only after passing these tests is the 3,000-ton tank installed. Floating cranes lower it into the hull with millimeter precision. It's a heart transplant on a massive scale. This tank is the ship's cold, beating heart, making green shipping possible. Without it, the revolution stops cold. Now, the engine, the WinGD 12X92DF. 5 stories tall, 2,300 tons, and the most powerful dual-fuel engine ever built. Assembled in a dedicated factory, its crankshaft and 12 car-size pistons are feats of engineering. At full power, it produces 85,000 horsepower, like 150 Formula One cars at once. Transporting it to the shipyard requires a special barge. Giant cranes hoist it into the ship, threading a skyscraper into a needle. The propeller shaft, over 100 meters long, must be perfectly straight, laser-aligned to avoid catastrophic vibrations. At the end, a 10-meter, 90-ton bronze propeller, balanced to perfection. Any imbalance could destroy the ship. Once installed, the engine, shaft, and propeller form a seamless powertrain. This is brute force and delicate precision combined. The heart and muscles of the Titan are finally united. The ship is ready to move oceans. Power, precision, and scale, unmatched. With the ship complete, the final tests begin. The hull is sandblasted and coated with high-tech paint to fight corrosion and marine life. A smooth hull means less drag and more efficiency. The command bridge, built on land, then lifted into place, becomes the ship's brain. Outfitted with advanced navigation and control systems, it's ready for a crew of just 26. Then, sea trials. The ship is floated, towed to open water, and pushed to its limits. Engines roar, steering is tested, and every system is scrutinized. Only after passing every test is the ship handed over. It's the result of millions of hours and thousands of hands. The CMA-CGM Jacques Sade and her sisters are more than ships. They're a leap toward cleaner trade, proof that even the biggest machines can change. Ambition, innovation, and a touch of madness. This is progress. The future of shipping has arrived. Thanks for watching. Curious to see more feats of engineering and innovation? Check out my next video. Watching now.